Hi, everybody. Today, we're going to start a new unit on inequalities. Right? And unlike our previous unit with equations, inequalities are mathematical sentences which express that one expression is not equal to another expression. And today, the focus of our lesson is to address the learning targets. Number one, I can translate inequalities. Two, I can read an inequality statement from the variable. And three, I can graph the solution set to an inequality on the number line. So by the end of this lesson, you should be able to do all three of those things. Just a couple seconds ago, I did mention that inequalities are unlike equations in that, an equation expresses that two expressions are equal in value, whereas an inequality shows that two expressions are not equal in value. So rather than seeing an equal sign like we do in equations, we're going to start looking at a couple different symbols with inequalities. So the symbols we use when we're talking about inequalities look something like this. We have this symbol, which when read left to right is greater than. We have this symbol, which is greater than or equal to, greater than or equal to. We've got this one, which is less than. And we've got this one, which is less than or equal to. Okay. One of the things that we need to keep in mind when we are working with inequalities is that inequalities can be read left to right or right to left. Okay, just like an equation, an equation we could technically read right to left as well. But inequalities, very often, we actually read from right to left. So let's just make note of that. How do we read inequalities? So inequalities, we need to make sure we mention that inequalities can be read in either direction. So inequalities can be read left to right, okay, or right to left. This becomes super important as we move forward when we are graphing inequalities. And remember, that's our third learning target for this lesson, is that you can graph the solution set to an inequality on the number line. Speaking of that learning target, I just want to point out something here. When we're talking about inequalities, now that it's no longer an equation, right? Remember, when we solve an equation, for example, the solution to an equation is the value of the variable which makes the equation true. And if the expressions have to be equal in an equation, well, oftentimes with linear equations anyway, there's only one possible solution to that, which makes the value of the variable true. But with inequalities now, we can get a whole host of values. In fact, there might be an infinite number of solutions, and so we're not going to call them necessarily a solution anymore, but we might reference them as a solution set, meaning it's the set of numbers which satisfy the inequality. We'll get a better sense of that as we look at the solutions graphically. But for right now, I want to go back and I want to talk about reading inequalities. So we did say we could read them left to right or right to left. So let's just, for example, let's take a look at this. It's very simple inequality, okay? All right. So if we read this left to right, it would read W is less than -3, right? So if we read that left to right, we would say W is, not less than, greater than. W is greater than -3. My brain was working faster than my pencil. I apologize. So W is greater than -3. Notice when we read left to right, we've got this symbol right here, which is greater than. But if we read it right to left, so in other words, we're starting with -3, we get -3 is less than W. So it's kind of the other way around, right? So we have to get used to reading both left to right and right to left. And, way back when you were first introduced to this idea of an inequality, and maybe your elementary school teacher used some kind of visual helper for you to remember which symbol meant what. Perhaps they used something like an alligator or something to tell you that the alligator eats the bigger number. Well, that was okay when you were in second grade, but when you're just looking at two quantities. But as you're reading an inequality statement, that becomes less helpful. So I don't want you to get hung up on that visual of that alligator eating the bigger thing. What I need you to do is I need you just to be able to read the inequality statement either left to right or right to left. Okay, so again, this would be W is greater than -3, or you can read it right to left and say -3 is less than W. So besides just the symbols, we also have some key words in some phrases which also indicate that we're talking about inequalities. Let me just first point out that, when we talked about translating expressions, we did have the key phrase less than, right? And we did say that when you see less than, that is subtraction, right? Subtraction. But this time we're talking about is less than, right? So is less than, that little word is becomes really important because that's what makes the distinction between the fact that we're talking about subtraction or we're talking about the inequality, the is less than symbol, okay? So just be on the lookout for that. Be on the lookout for less than versus is less than. So, for example, if I say 2 less than x, right? 2 less than x would be x minus 2. But if I say 2 is less than x, 2 is less than x, then that would look like 2 is less than x with the inequality symbol. So I know that's kind of strange, but that's definitely something that you're going to have to keep in mind as you read inequalities and translate inequality statements. There are other words that translate to inequalities. Sometimes you'll see words like at most. Okay, so at most translates to greater than or equal to, right? Less than or equal to. Less than or equal to. At least. So here's at least translates to greater than or equal to. You might see like something has a maximum. So a maximum means that it has to be less than or equal to, or the words minimum, right? A minimum means that something has to be greater than or equal to. So for example, like my bank requires that my checking account have a minimum of $100 in it, right? Which means that I have to keep more than or equal to $100 in my bank account at all times. So again, we see these words at most or at least, maximum or minimum. Let's just say, an example of this would be John has at most $30 in his wallet. Okay, so if John has at most $30 in his wallet, what does that mean? That means the amount of money that he has in his wallet, we'll call that M for money. The money he has in his wallet is less than or equal to $30, right? So he can't have any more than $30 in his wallet, so it has to be less than or equal to $30. If I run at least 5 miles a day, that means the miles that I run have to be greater than or equal to 5, right? So again, we see these words which translate directly to inequalities. All right, so I'm going to call this part 1 of Introduction to Inequality Statements. You're going to continue on with this lesson. We sort of addressed number 1 and number 2 of the learning targets in this video. You can continue on to the next video, and then we will take a look at learning target number